Welcome to a lesson with Dr. Powell. Let's take a look at what happens in a power set poset when something, so some kind of subset of a set S, say, a set of everything, which we'll actually think about just as one. We'll use the symbol one to mean a set of everything here, or kind of reference to true. So what happens when a subset is merged to true in a merge or a function that preserves unions and intersections? Well, first of all, if this is merged up there and you're going to preserve intersections and unions, it's like a blockout map, or it's like in kind of ignoring type deal, like I've described in another video. Namely, if you think about the subset of A as being notated with zeros and ones, then the map is going to, if you have a sequence of zeros and ones, whatever it is, basically the types of maps that work here are of the kind of just ignoring certain entries. So for instance, here, what entries would we ignore? So the minimal merge that would actually merge this guy to that guy would be the one that ignores everything that you have to add on to A to get to 1. Well, anything along the way, if you add something on or another thing, whatever, you're going to get to different subsets. And those are the subsets that are between A and 1. So if A merges to 1, then that means everything between A and 1 also merge up to 1. Similarly, thinking about intersections, what happens if A and 0 merge together? Well, then you also have this ignoring map. And essentially what is ignored is everything that's not, what's ignored basically is you're pretending that everything in A is 0. So any subset of A is going to be a subset of 0. So it's also going to naturally be 0. So this is the mechanics and why sandwich swallowing, which I've described in another video, actually works. Let's explain a little bit as well again. So if you have a Boolean algebraic expression, let's suppose it's represented by a set A, say, and if you can show that a sub-expression, if setting a sub-expression to true, forces A to true as well, there's only one way that could have occurred. A would have had to have been in between E and 1, or E would have to have been below A. And that has to do with how this minimal merging map works. The only things that actually go to 1 are the things that are actually in between E and 1, because of how it's described with this blockout map of what is ignored minimally. So for sure, we're going to get that E is going to lie below A. Now, if E lies below A, then you can freely say that A is equal to A union E. And what does that mean? Well, that means that E can come in. If A is written in disjunctive normal form, then E can come on and when it unions with something that is when it unions with something that's smaller than it, or that's a subset of it, it can swallow it whole and eat it up. And so it actually simplifies your Boolean algebraic expression. Similarly, over here, you have the same basic idea with an E and a 0 and your A. If forcing E to 0 at minimum forces A to 0, that must mean that A is between 0 and E. So A is a subset of E, which means that E is equal to E intersect A. So that if this is in conjunctive normal form, A can come in, and if A happens to be a subset itself of something, then intersecting with it, it'll swallow it up as it goes along. And so you'll simplify your expression. Thanks for watching.